Well, good morning. Once again, I'm Tim Hale over here to talk about tomorrow's severe weather threat. And right now, it's looking like we have the potential for severe weather again in this central U.S., right? And let's take a look real quickly at the parameters here and what the SPC has to say about it. The Storm Prediction Center, meaning the SPC Storm Prediction Center here. So what we got a enhanced risk here encompassing a good portion of Kansas and into Missouri here. Kansas City, Beatrice, down towards Anthony, Wichita, and a large marginal risk and a slight risk around that. So, what are the threats involved with this? At least the possibility of strong tornadoes here. Anywhere in this hatched area up to EF2 are possible. All right. This is for tomorrow, guys. This is tomorrow's tornado outlook. So, we have a small area here where there's a 15% chance of strong tornadoes. The brown area is a 5% chance of strong tornadoes. And outside this area in the hatched region, there's still a 2% of strong tornadoes. And this other area, less than EF2 tornadoes are expected. Okay. So that's a reasonable expectation of EF2 tornadoes within this hatched area here, right? With the highest probability centered in this yellow 15% risk. And then the wind risk for tomorrow. We have a pretty large wind risk that encompasses parts of Kansas here, southern Nebraska, Missouri, pretty much the whole threat area. 30% chance of 50-knot winds or greater within 25 miles of a given location. Then the 15% risk in the yellow and the 5% risk here in the brown. All right, so hail. We also had the potential for up to 2-inch size hail, 2-inch hail here in the stippled region. All right, which 30% chance within the red area here. Okay, Kansas City, Wichita, Kansas, up towards Beatrice, Nebraska here. And you see the slight risk area, 15%, and the 5% risk encompassing the rest of the severe threat, right? But you can see where this goes down to 15% risk, you still have 15% chance within 25 miles of a given location of having 2-inch hail. So kind of a lot to explain here, but that's the threat for tomorrow. Excuse me, not today, tomorrow. So what's driving this threat tomorrow? Well, we're into the evening hours and in the morning hours here, and this is the NAM 3-kilometer CONUS, right? And the Storm Prediction Center has talked about there's still some uncertainty about the timing of different short waves are moving through the flow here, right? And you look at 9 a.m. roughly here tomorrow, right? And what we see, oops, sorry about that, is looks like maybe a short wave moving through here, and maybe another short wave moving through the flow here. This is 9 a.m., okay, to start with. You move through a little bit more with this as shortwave moves off, 4 p.m. And you can see this is at what level we're at, 700 millibars. So a good way to look at shortwaves here. And you see the flow really starts to get enhanced here. And what looks like another shortwave, maybe in the flow right here. Shortwave meaning like a little bit of a kink in the flow, which could enhance lift enough to trigger storms. And maybe another one back here. Okay. So that has been noted by the Storm Prediction Center about timing issues with this. So, I think tomorrow's threat is going to be is actually less certain than on Monday's threat, but we're focused on today. All right. Remember where we show the threat area is generally, um, if I remember right, in here, right? So let's go back. Yeah, Colorado's there. Okay. So just getting my bearings here, guys. Sorry about that. All right. So the convective evolution here. Let's take a look at that real quick, starting in the morning hours. right, like 5 a.m. So let's look at the, I know I'm spending a lot of time on this, but hope y'all appreciate what I'm doing here. The NAM has our storms that are, already fired here in Texas, Oklahoma, moving to the southeast. And you see, it's not very bullish on getting any supercellular activity going anytime during this. Maybe some on maybe an outflow counter boundary here to the east, but you see convective initiation, there's not much, right? But what I've noticed is my picture disappeared on the screen, but what I've noticed is the other models are much more bullish. So you take a look at the HRRR around the same time. Wants to fire our convection here in the evening hours. There's some rotating storms here, some pretty significant updrafts. We get 48 hours out from now, and that's as far as it goes. All right, so we'll get a little bit further out here. Now we're on a more recent run of the HRR. Wants to fire up some convection early in the period here as that short wave moves through, maybe, and then maybe a few supercells again afterwards. I think the evolution of this initial convection may and probably will play a factor in whether we get convection firing behind it and how much it works over the atmosphere. Okay, so if you look back at the HRR a while back here, a 6Z run, let's just say, it had a lot more supercells firing afterwards. So it's actually trended downward since about 6 hours ago. So that's one model, okay? So here we are with the Rufus, another model output here. You see initially, look at this. This is today's Rufus output. This is one of the convection line models. A lot of supercells here. It usually does things. So that's probably not how it's gonna evolve, but it's gonna be a busy day here today, right? So in the 2 a.m. tomorrow, 3 a.m., 2 p.m. Once it fires some storms up here into northern Kansas, and on the back side of this, maybe some elevated convection here. All right. And then really wants to get maybe an MCS type feature or different lines of convection pushing through here into the overnight hours into early Monday morning. And that moves through. So a lot of uncertainty given the difference in models here. So let's look at a couple other ones. This is the MPAS model. Another convective allowing model here, 4 a.m., 5 a.m., into the afternoon and evening hours. Wants to kind of like the HRRR and on the NAM, maybe want to bring some convection in initially, which could impact the atmosphere later on, but does want to develop a few supercells here, isolated storms early in the evening hours. So that's one more. So we'll look at one more model real quick just so you have an idea of the differences here. This is the Severe Storms Laboratory NSSL MPAS 426 tomorrow morning. Once a fire off convection to the north here. Really doesn't have a lot going on with the exception of up here. Right? No supercells firing in Kansas and Missouri. Maybe up here in the northern portion of it. If you remember, this is where our severe threat is focused, right? So we'll just have to see how this convection evolves tomorrow. Quickly here, I'm going to take a couple soundings from the threat area here, right? As this line of storms is 6 p.m. Eastern, which is 5 p.m. Central. This is the HRRR model. And let's take a sounding here from central Kansas here real quick. Let's see, pull up here. Marginal tornado parameters here. A pretty uncapped environment at this point. Let's go back a little bit with this. Marginal tornado parameters. Marginal severe. Some interference here from some corruption here of the data with rainfall and convection ongoing, right? So I'm moving through time here a little bit. Let's see how this parameter space ends up. In this area, it seems like the cape is pretty skinny here with some dry air at the surface, although not a big spread here. Pretty skinny cape, which tells me that, not a lot of energy here. The, the photograph here is pretty meager as far as curvature goes. So, and based on that, this sounding wants to say, hey, we could possibly have an EF1 or EF2 tornado here, low end chance, right? So let's take another sounding. Let's move a little bit further in time here. After that convection moves out, these supercells maybe getting going here. A little bit further, how about further to the west here? Yeah, so let's see what time this is. This is 01Z, so it's in the evening hours. Let's go back a little bit, and we're back to this tornado thing here, right? But we see it's capped. We have a little bit of a cap building here at different levels, like right a low level inversion and one near roughly 600-700 millibars, but you see some contamination here as well, maybe convection coming through there, right? Moving through time a little bit, you kind of lose that, right? So let's take up more soundings here and take a look at some other parameters in different areas. How about down into Oklahoma here? Going back a little bit, relatively meager cape here as well. Very skinny cape here. So most likely elevated convection here, if you ask me, but not a lot of significance to anything, at least right now. I mean, we're going to have severe weather, I think, but how impactful it is, we'll see here. So let's look up here. We go back to the severe threat tomorrow. You see where it's centered, right? Where the tornado threat is. I'm going to take a sounding right from up there in this area, okay? And we'll look at that real quick. Pretty much the same thing here. I don't know. Let's go back in time a little bit. I'm taking some time doing this. I don't know. There's you have a time period in here. This is 20Z, so 8 p.m., which is roughly around 4 p.m., where you have just the cape is the atmosphere. Let's see, a little bit of a cap here to start with, so that may help things, but the surface temperatures seem pretty low here as well. Let's take a look at the NAM, see what it shows here. Take a sounding up in this area. Come on, it's not wanting to work for me. Here we go. Please do it. All right, well, that didn't work. So, let's go back a bit here. I'm going to look at dew points real quick and some other parameters so we can see what's really going on here. So to start off with, this is the morning hours, maybe a surface low in Texas here developing. You see the dew points, 60-degree dew points up to the north here. You see where the 70-degree dew points are, right? And that surface low kind of disappears from the picture here, and just kind of a nebulous forcing here, right? And not a lot of certainty about, and maybe you see through the morning hours, a surface low may be going here. That tends to make me think that, we may not get any convection till way early in the morning here, right? If we do. So let's look at a couple other parameters here for instability and things like that. And then we'll call it a day for this part of the forecast. You can see mixed layer CAPE here, which is a measure of the energy in the atmosphere throughout the column. Not very impressive for our area of interest until way overnight here. The lapse rates look to be steeper, and you have the surface low really getting going here, maybe pushing this line to the east. So that tells me, again, we got a late overnight event, if anything here, right? Some pretty extreme instability down to the southern mode of this. But if you remember, the reflectivity here is HRRR. Let's see where we're at with this. Control Z. This is 9 p.m. Wants to fire some storms here, but they really don't get going. All right, so let's look at the sounding here real quick. One more thing here. Very dry profile at the low levels. So that's probably what's preventing convection from really getting going here. The cap at the low levels as well. So low level inversion, 85, 58, dew point, temperature spread, inverted profile, could be large hail, right? But not likely tornado threat in this area. And pretty straight photographs here. See, not a lot of curvature. It's like a lot of shear, but not a lot of curvature. So I don't know. We'll see how this goes, guys. But tomorrow, I'm not too bullish on right now. We'll have to see how this evolves during the day, and as it comes more into focus tomorrow, we can talk about it again. Appreciate y'all watching. Have a great afternoon. Be safe out there. God bless y'all.